Another chemistry video, and today's video is on covalent bonding and properties, and it's aimed at GCSE and AS students. So first of all, you need to know the two different structures of molecules and compounds that contain covalent bonds. So the two different structures are simple molecular and giant covalent. So we're going to start off with simple molecular. So if you look at the diagram on the right, this is what a typical simple molecular structure looks like. So there's strong covalent bonds between the atoms, and then there's also weak intermolecular forces of attraction between these covalent bonds. Examples of compounds with a simple molecular structure are water, oxygen, and NH3. So if you were to describe the structure of a simple molecular compound, you would say that it has a simple molecular lattice. It's really important that you say the lattice as well. So, in a simple molecular compound with a simple molecular lattice structure, there will be a low melting point. And this is because they only have weak intermolecular forces that need to be overcome to change their state. And this means little energy is required. So here's on the right some examples of the weak intermolecular forces. These include London forces, hydrogen bonding, and the permanent dipole-dipole. Note, this is specifically for AS students in terms of knowing the actual weak intermolecular forces. You do not need to know it for GCSE. So, simple molecular lattice structures don't conduct electricity, and this is because there are no free electrons, as all the electrons are in shells or bonds, so current can't flow. This means that they are not conductors. It also means that they have poor solubility, and that means that they don't really dissolve in polar solvents, but they will dissolve in non-polar solvents, and this is because London forces in the simple molecular structure can form bonds between the solvent and solute, and this means that the simple molecular lattice is broken down. So basically, the bonds between the compound and the water, which is an example of a non-polar solvent, will cause it to break down. So now this is the second structure of covalent compounds, and that is giant covalent structures. And this means that they have a structure called a giant covalent lattice. So just a common thing, they literally always end in lattice. Make sure you include that. So examples of these are diamond, silicon dioxide, graphite, and graphene. And they have a very high melting point compared to a simple molecular structure, and this is because the covalent bonds have to be broken, and that's because there are no intermolecular forces in giant covalent lattices compared to simple molecular, which does have intermolecular forces, and that means a large amount of energy is needed to break these covalent bonds. And here's just a note about specific giant covalent lattice structures and their electrical conductivity. So AS students, you do need to know that diamond doesn't conduct electricity, and that's because it has no free electrons or any charged particles. And graphite and graphene, they can conduct electricity because each structure has a lattice of hexagonal rings of carbon, with each carbon being bonded to 3 others, leaving it with 1 free electron, because carbon can form 4 bonds. So that 1 free electron can move and carry the charge, which means that graphite and graphene can both conduct electricity. So the difference between graphene and graphite is that graphene has a single layer of rings of carbon atoms, whereas graphite has multiple layers. The layers in graphite are held together by an electrostatic force of attraction. This is very weak and means that layers can slide over each other. So, the solubility of giant covalent lattice structures. They are insoluble in any solvent, and this is because the strength and number of covalent bonds that need to be broken is far too much, and the energy is far too much that is required to dissolve these substances. So you need to know that giant covalent lattice structures are not soluble at all. So that is all. Thank you for listening and watching, and I hope you enjoy the video and subscribe for more content.